All right, so we're going to continue working with complex numbers. We're going to simplify some expressions that involve complex numbers, starting with problem number 54. So problem 54 looks like this. Square root of negative 81 over 16. What I would suggest is that we break this up into two parts. Actually, maybe three parts. You can write it as the square root of 81 times the square root of negative 1 over the square root of 16. And then simplify each of the parts. Now, I don't think we need to break out our calculators here. Square root of 81 is 9. Square root of 16 is 4. Square root of negative 1 is I. But when you're working with these complex numbers, or these expressions that involve a negative square root, get rid of that negative right away, because it can make a difference depending on the order that you do things. An example would be problem number 60. We've got the square root of negative 36 over the square root of negative 2 times the square root of negative 9. So your first order of business is to get rid of the negatives underneath the square root. Don't multiply this together and get the square root of 18. Okay, that might lead you a little bit astray. So I'll write that as the square root of 36 times the square root of negative 1, square root of 2 times the square root of negative 1, square root of 9 times the square root of negative 1. So notice I've first got rid of all the negatives underneath the square roots except for where I've got some terms that are going to turn into an I. How can I simplify the numerator? What should I write? 6i. Square root of 2 times I, and then square root of 9 times I. Oops. Let's get back on the screen. Now, I times I in the denominator is going to give me an I squared. So I'll have an I squared here. Square root of 9 is 3. So I have 3 times the square root of 2 times I squared. And the numerator is still just 6i. There's a little bit more that I can do here to simplify problem number 60. What is it? What can I do? We could, but I'd rather simplify it based on the denominator. What can we do with the I squared? What's I squared? Negative 1. Perfect. So this is 6i over negative 3 square roots of 2. And I can write the negative out in front. 6i over 3 square roots of 2. Last but not least, I guess we can cancel out 3 into 6 and end up with negative 2i over the square root of 2. Now, if I really wanted to be hardcore, you could continue rationalizing this and end up with square root of 2, or negative I times the square root of 2. You know, I guess I'm pretty happy with this as it is here. I don't want to make this problem too insane, but you can go a little bit farther. At least get here. The point of this, though, is in how you simplify these things. You do not want to multiply this together and get the square root of 18 in the denominator. If you did, then you'd end up with the wrong sign here when you're all done. So, once again, what I want you to get is simplify the square roots first by factoring out the negative, and then simplify everything else. Now, complex numbers were introduced to solve equations. So let's see where they're used in solving equations, starting with problem number 62. So 3x squared plus 1 equals 0. Because there's no middle term, there's no term in x, what you could do is move the 1 to the right-hand side. When I move it to the right-hand side, what do I get? negative 1. It changes signs. Divide by 3. Then what? Yeah, take the square root on both sides. Thanks, Lucas. So I get x equals plus or minus the square root of negative 1/3. Now, just like the previous problem, we're going to get rid of that negative first. I'll write that as the square root of 1/3 times the square root of negative 1. And we are going to go a little bit farther on this one than we did with the last one. Let's plus or minus the square root of 1 over the square root of 3 times I. Square root of 1, of course, is just 1. But if I wanted to rationalize this, what would I have to multiply by to get rid of the square root of 3 in the denominator? Does anyone remember that one? Root 3 over root 3. So it would leave me with plus or minus the square root of 3 over the square root of 9. The square root of 9 is 3. By the way, your calculator is only kind of a limited value with you, for you on a problem like this, because it's not going to be able to turn the decimal value into something that looks like this. You can compare this to the decimal value, but it's not going to be able to recreate square root of 3 over 3. All right, at least get this far. Plus or minus 1 over root 3i, or better yet, even here. I think I'd like you to get there for problem number 62. Let's try some more here in terms of equations that result in complex solutions. And this is something you can reasonably expect on an exam. We've got x squared plus 2x plus 2 equals 0. What kind of equation is this? It's a quadratic equation. So can you factor this? You can? Are there two numbers that multiply to 2 and add to 2? No. So if you can't factor it, this doesn't look like a square root property one. What other alternative do we have? Quadratic formula, good. So who remembers the quadratic formula? Oh God, yeah. Oh, yeah. B squared minus 4ac over 2a. All right, good. So you need to have this thing memorized for the entire course. It will come up often enough that you want to have this one memorized. So, okay. Well, got to use the quadratic formula. A is 1, B is 2, C is 2. Let's fill it in. We get x is negative of 2 plus or minus the square root of b, which is 2, squared, minus 4 times a times c over 2 times a, 2 times 1. Now there's something magical that happens when people do this problem. When they simplify the numerator, plus or minus the square root of 4 minus 8, they get negative 2 plus or minus the square root of 4. What magic has happened here? Well, denial's not just a river in Egypt, right? All right. There's a negative here. You have to deal with that square root of a negative number. So square root of negative 4 is what? All right. Square root of 4 times square root of negative 1. And how's that going to simplify? 2i. Now there's another really wonderful thing that happens when people work this problem. People cancel the 2 and get negative 1 plus or minus 2i. Let me tell you that that's wrong. Can't do that. I'll give you two different options. I like the first one. The second one works as well. What you should do is factor out the GCF in the numerator. So I can factor out a 2. That's going to leave behind negative 1 plus or minus I over 2. And now I can cancel. I can cancel because I'm not canceling into a parenthesis. So I'm left with negative 1 plus or minus I. So that's one way to handle this. Another way to work on these problems, if you wanted to simplify this, again, in a mathematically correct way, would be to take negative 2 plus or minus 2I over 2 and divide each of those terms in the numerator by the term in the denominator. And this is a very safe way to do it as well. The 2's cancel, I'm left with negative 1 plus or minus I. So one way or another, you should end up with negative 1 plus or minus I. Okay, any kind of wrap-up thoughts on problem number 64 here?
You said that's one to look to on the test?
I would expect that you should be ready for solving a quadratic equation that has complex solutions. Yeah, definitely. Let's try another one kind of like that. Actually, very much like that. Problem number 66. So x squared minus 6x plus 10 equals 0. Oops. A quick look at this tells you it doesn't factor. So what's that give you? What's that leave you in terms of your options? Quadratic formula. Now, one like this requires a little bit more care because of the coefficients. What am I going to use for b? Negative 6. And the place people make a mistake, there's actually two of them when you're filling in the quadratic formula, is forgetting that there's a double negative when you fill in the 6. So it's the negative of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 10 over 2 times 1. So it's easy to forget the double negative. And it's easy to forget that when you square this, you get a positive 36. You got to square that negative as well. So a couple places to be on guard for. I always substitute my values in here with parentheses. That way I'm a little less likely to make a mistake with the signs. But why don't you see if you can't simplify this and come up with the right answer. All right, so as we simplify this, double negatives cancel. I get a positive 6. 36 minus 40 gives me 6 plus or minus the square root of negative 4 over 2. That negative 4 can be written as the square root of 4 times the square root of negative 1. So overall, I get 6 plus or minus 2i over 2. Now, it's my preference that I like factoring this, so I'm going to factor out the 2. Factoring out a 2 here leaves me 3 plus or minus 1 times I, or better yet, just I. The 2's can then cancel, and I'm left with 3 plus or minus I. How many people got that one right? Yay, good job. Good job. One last little quick thing here for us. Problems 48 and 52 refer to powers of I. And there's a little bit of a pattern in powers of I. I'm not going to make a big thing of it, but I will show you a little bit of a trick. The one power of I that I asked you that you know for sure is I squared. What's I squared? Negative 1. So how can I use I squared in simplifying I to the 10th? Well, what if I wrote I to the 10th as I squared to some other power? The 5th power. Now let's simplify what's in the middle here. Do you see that these two things are equal, right? 5 times 2 is 10, so I've just rewritten this. So that's negative 1 to the 5th power. What's negative 1 to the 5th power? You've got an odd exponent here, so you're going to get a positive or negative 1 for an answer. Negative. So negative 1. And that's it. All you're doing is you're just taking advantage of the fact that you know what I squared is. Now your calculator can actually do this accurately up to really large powers of I. But again, I like to see the work. And at some point, say around 700, I think, it starts to give you the wrong answer. But algebraically, we can work it like we did problem 48. So I'll write this as I squared, but I want to write some power there. So, Michael, what power could I write there? Good, 501. So this is negative 1 to the 501 power. Thanks, Michael. So, Ruta, what's negative 1 to the 501 power going to give me? Negative 1. Beautiful. For homework, try 7 through 41 and 47 through 67. That's section 1.6. And the homework for that section starts on page 64. Let's see if I still have volume. Yes, good deal. So hopefully we got a good record on that one.